I'd like to give you an indication of what's custom design in Jump Pro 11. So when you open custom design, open Jump, then DOE, then custom design, you're afforded the opportunities to have Jump construct some designs. So all you need is a response Y, that's already in there. Notice we have a choice of maximize, match target, or minimize, or just leave it at maximize for this illustration. And then we can add factors. And what I'd like you to be able to do is exactly what I'm doing here today, and that's with, suppose we have 7 factors, make them continuous. Now we have them, and I like to use the letter designations rather than x1, x2. It's equivalent, but I'm just used to the letters. I'll set it on caps and change them to A. So I can get it to work. A, down, B, down, C, arrow down, D, arrow down, E. This here, oops, what I do here. Arrow down, F, does that work? No, I gotta do it again. F and G. So I have those 7 factors to deal with. So there we go, double click, now I can do a D. Alright, I got 8 B, C, D. So I continue. And I'm going to use 16 runs just as, again, because that's kind of our standard. As you're learning DOE, it's helpful to have that number. We can change it later for other cases. 16, and then in Jump you can do make design. So it'll go ahead and find the design. At this point, it's just saying for these factors we would like to estimate the main effects. We could have also done second order interactions, and we'll actually highlight these and then do second order interactions. Okay. What am I doing here? Okay, let me just not worry about the interactions for now. I'll move back to let's create this design, and then I'll show you what I really want you to be able to do. Make design. It's gone ahead and created a design for us. It's done some numerical calculations to find the most precise design available. There's also a bunch of other options that we could look at in terms of simulating some phony data. But what I want to do here is just let's have a look at the design and see if we can kind of reverse engineer, see what custom design has done. Now the table as given is hard to look at because it's a jumbled mess of -1s and +1s in no particular order. So let me go ahead and say when I'm going to create a table, then I can look at the table. I'll sort left to right and then make a table. And change the font size, so hopefully this is a little easier to read. I'm still puzzled why it's a little bit blurry, but hopefully you can still read through it. So bunch of minuses, 8 minuses, 8 pluses, 4 minuses, 4 pluses, 4 minus, 4 plus, 2 minus, 2 plus, and so on. And now you see we don't have minus, plus, so forth. So it doesn't look like A, B, C, D in custom design is going to give us all the various combinations. So let's see, to track that, to try to figure out, well, how many cases are represented here for A, B, C, D. If I highlight those columns and go to tables summary and then do group, since these are already highlighted, do group, Jump's going to go ahead and find out how many possibilities are. Well, there's 12, and there were some repeats. These rows had repeats, these rows had repeats. We need to see 16 here if all combinations are available, which they're not for these columns A, B, C, D. That doesn't mean there's not some other combination of columns for which there's all combinations. We can just kind of do a check. So tables, summary, D, E, F, G. Okay, all 16 are represented here. So D, E, F, G out of those original 7 columns do correspond to all 16 combos. So that means we have a full factorial in D, E, F, and G. And now I'd like to know, well, how are A, B, and C related to our base columns D, E, F, G? Well, I can just go ahead and use jump to figure it out, analyze, fit model, and I want to see how those columns A, B, C, D, I don't care about Y, there's no Y in there, A, B, C relate to my other base D, E, F, G columns. So these I want out. I'll highlight D, E, F, G, and then do full factorial. So I'm interested in how do the columns A, B, C relate to the individual columns, products of columns, triples of columns, quadruples of columns, and let jump do the work for us rather than us trying to guess what columns are what. I run it, and what did it do? Well, it said A is equal to a half DF, a half EF, a half DFG minus a half EFG. So that's what a model would give for that for A. Likewise, B is a function of 4 different columns, and C is a function of 4 different columns. So it's partially confounded or explained by these higher order terms: a two-way, a three-way, and a four-way. So this happens often when you use custom design to generate design. There's a lot of possibilities. Sometimes you get this, sometimes you get other kinds of situations. So that's one possible depiction of what jump has produced numerically, and now we have it explained in terms of the letters. Let me do one more, see if we get something. Since it's random. Let me see. Do I want to do that? Oh, let's just leave it. Just do another one here from scratch. DOE, custom design, 7 factors. Add the factors, continuous, x through x7. Okay, let's just leave it as x's to show you there's no big deal. You don't have to change it if you're comfortable with x1 through x7. Continue. 16 runs. Type that in. User specified, and then find me a design to estimate this stuff. Make design. So it's done it. It's hard to look at this table and figure out what's going on. So I'll present it left to right, make table. And here again, the things don't look like it's x1, x2. There's the 4 minuses, 4 pluses, and then this is mixed up, so I don't think those are going to give us all 4. We can check it with tables summary. I'm just looking for any 4 columns that do the trick to give me 16 combinations. So that only has 12. Let's try another set. Tables, summary, group, 12. And then it gets to be a little bit painful trying to guess which ones are there 4 that exist for that. There's a lot to choose. Tables, maybe we'll be lucky here. Table summary, group. Okay, there's 12. So here we may have a case that's not so easy to figure out. Let's see. Try again. Summary. 12. So it looks like I may have one of these not so easy to figure out. That one didn't work. Let's see. So at some point, it's, well, certainly x1 and x2 look promising. So there's another couple of columns that might do the trick. Now let's see. Did we try these two? And table summary. 12. Really locked into 12. I've had situations where I've had to check it pretty exhaustively. Let's try that. Just kind of guessing. At some point, we have to do it systematically. Be nice to luck out. No. Try one more, and then I may abandon it and have to do it offline and then get back to you as to what, if any, there are. I may have to check a zillion. Hey, what do you know? X1, X2, X5, X6. Wonderful. So, we know those are, that gives us all 16 combinations. So let me just call those X1, X2, X5, X6. Call that A, this B, this C, this D. And now let's see what the other ones are in terms of A, B, C, D. Analyze, fit model. And we want get rid of Y. And we want the X's in terms of these other columns, in terms of A, B, C, D. So I remove those. And then I'll highlight A, B, C, D. Do full factorial. A, B, A, B, C, A, C, B, C, A, B, C. We can get the rest of these then by just kind of taking D times all of these. AD, BD, ABD, CD, ACD, BCD, ABCD. Exactly what's given there. Let her run. And this time column X3 is a function of 4 of them, 4 of them, 4 of them again. Sometimes they come out to be just a single three-way interaction that you have to try a few to see how it turns out. So that's to illustrate how we can kind of reverse engineer how these designs can be constructed in terms of a base 4-column full factorial and then for 4 of the columns, and then the other 3 as functions of 4 of the two-way or higher interactions. Let me stop there.